Hi, it's good to know you there. It's good to know you are watching this. This is your inventor, Nandom, and I'm very, very glad to be back again with something new, very, very new for you. This is our first class on instruments and components, or components and instruments. In this class, you will be learning quite a lot, especially as it relates to testing of components, as mentioned already, and also how to use certain laboratory instruments. In this first class, we are going to begin with the multimeter. You're going to learn how to configure the multimeter, how to make use of it, and then in subsequent classes, you will learn how to get the correct measurement or reading of a certain component to get to know if they're working or not working at all. This is a very, very useful class for engineers or engineering students and those who have passion for engineering generally. So whether you're in the field, in the classroom, the workshop, in the laboratory, I can assure you that this video and the subsequent videos will be very, very useful to you. If you're yet to subscribe to my YouTube channel, I will be very glad if you're able to do that so that you will be notified whenever a new video is uploaded. Thank you, thumbs up to you, and keep following. Okay, hi. So this is our practical session, and I want to take you through the multimeter to teach you a few things you need to know. Some of the things you're unable to learn here when we begin our component test, um, you are going to get to see them. So this multimeter is quite new. This is the pack. You can see it, quite new. And when you unpack your multimeter, one of the first things you need to do is to ensure that you have your probes. These are called the probes. You have to ensure that they are intact and preferably coming in different colors. I will be verifying. Now, these colors do not matter much as far as the conductivity of these probes is concerned, but it's very important, very key to have different colors so you can easily identify which one is going to live, which one is going to neutral, or which one is going to positive, and which one is going to negative. Now, after checking your probes and then you're sure that you're okay, then you go to the next thing, you insert them, and then you begin your test. Now, but before we do that, I would want to tell you a few things about this multimeter particularly. Now, this multimeter is a digital multimeter, that's one, and secondly, it is an auto range multimeter. Digital multimeter in the sense that the outcome or the display you get to see is in mathematical form or numerical form, but not in the form where you have to see a needle deflecting from left to right or up and down. Secondly, it is auto range because it automatically configures itself to give you the exact value or to display for you the exact value of whatever it is you're testing, so you don't have to do a preset maybe between 5 and 10, 50 and 100, 200 and 2000 thereabout, which makes this a very nice instrument for use in the laboratory or electronics workshop. Now, the next thing I would want you to see are these holes. We have 4 of them. 3 of them are the same color, 1 of them is black, and here for this we have A on top of it. A is for ampere, then we have red, another red here. This is MA, which is milliampere, and then we have a symbol beside it. This symbol is for clamp meter, which shows that this is for measuring current. The only black one we have here, this is COM or common. Now, common usually shows or indicates the return path of your power of your test, whatever it is you're doing. The return path is usually the common. This is another red one. We have various tests that can be carried out through here. We have V, we have, which is voltage, we have symbol for resistance, we have F for frequency, we have C for capacitance, and then we have X for representing other things that we may need to test. Okay, that being said, I can slot my black probe here, and then it goes in smoothly without challenge. I go for the black one, the red one, sorry, go for the red one, I slot it in, and then it goes right inside. Now, before we're able to test anything such as a continuity test, there are very important things that you need to know written all around this setting. Currently, the setting is on off. We have another off setting here. Now, but this is the pointer on this side here. Now we have V with a little wavy sign or wave sign beside it. This shows that this is alternating current voltage. So by the time I configure this to this point, now what I will have is setting for me to measure alternating current voltage. Now we have a V on this side with straight lines beside it. That's another voltage, but in this case is direct current voltage. The next one we have here is a symbol for resistance, which is the ohms. Here we have, this is a setting for two measurements. You have one sign for continuity, and then we have another sign for the diode test. The next one here is CAP or cap, which is the test for capacitors or capacitance. The next one is the HZ or the frequency. Now we have another thing here referred to as the HFE. It has its meaning. Basically, this is used for transistor test, and it simply means hybrid parameter, forward current gain, common emitter. So this, once our setting is at this point, of course this works with this, and beside this we have the NPN and then the PNP depending on our transistor test. Of course, when it's time to test our transistor, we're going to see how that is done and how we can carry out our test effectively. This is another symbol here for the clamp meter. Now down here we have micro A or mu A, so this is microampere, and then we have MA, which is the milliampere, and then we have the ampere test, that's the current. Now the next thing is how to calibrate our multimeter. Now is on off, so if I want to measure alternating current voltage, I just shift this way and my pointer comes here. So here I have AC. Okay, so AC, then down here I have V. Okay, now we can have some very small or very little readings on the screen because there are charges all around, so probably the multimeter is picking some charges, and that's why we have very small value there on the screen, 0.003. To get to DC, I shift it to the next one, so this is DC voltage, and then I can get it to any point I need to get it to. So since this is an introductory class, we can carry out the test but not component test, and the continuity test, we can actually do that. So let's get to this point and see if we can do that. So now we have our pointer here. Here we have diode symbol here, and then we have OL, which means overload. So on this setting, this is what you see. So but then when you begin to carry out your test, especially testing diode, you should be able to see something totally different. So when it's time to test our diode, of course we will do that, and then we're going to see what the display will be. Now to measure or test the continuity of this multimeter, now I can use this button. If I press it, it sounds, the symbol here changes. If I press it, it changes. It goes here continuously like that. So I can leave this on continuity. Now why is continuity so important in multimeter? Now, continuity is so important because whenever you need to test conductivity or continuity of a metal or serviceability status of a component, whatever it is you need to do, you have to be sure that your multimeter is in good shape. Because by the time you begin carrying out your test, you wouldn't be so sure if your component or your system or whatever it is you're testing, you wouldn't be so sure if it's working very well, not working completely, or partially working. But by the time you're very sure that your multimeter is working very fine, then you can confidently carry out your test. And then whatever display, whatever outcome you see on the screen should tell you exactly what is happening at that moment, so you can carry out the decisions or take whatever decisions you need to take. Now, to measure my continuity, it's already on continuity. All I need to do is to bridge these two terminals together. Yeah, get to hear this? You can hear? It sounds. It's telling me clearly that my multimeter is working very, very fine. Okay, I'm really glad and happy to know that you've watched this video up until this point. Please, if you're yet to subscribe to my YouTube channel, try and do that so that whenever I upload new videos, you will be notified. I hope to see you in the next class, and where you would get to see components being tested and how you can make use of your multimeter. Kindly comment if you have any questions, and kindly comment also if you have any other thing to say. Thank you for following. Take care.